Everyone, it's Shubho Shetty with Show's Solution. This is the video by the troubleshooter of your mass phobia. If you feel it's worth of watching, please take a second to hit like and subscribe to our channel. Well, dear students, let's move to the next concept. Before you go to this, please make sure that you are perfect my all previous videos. So, dear students, let's move to now vector of joining 2 points. Vector of joining 2 points. Now let me take here 2 points A and B. Let me take 2 points A and B with coordinates let A be the initial point with coordinates x1, y1, z1 and B be the terminal point with x2, y2, z2. So A and B be the 2 points. A, B be the vectors with A as the initial and B as the terminal points with some particular coordinates. Okay. Now I want to find out the components of this vector AB. I want to find out the components of vector AB. So already we know we have studied components of vector, particular given vector. In that components, scalar vector may be or scalar components may be or vector components may be. Correct? Same thing. I want to find out the here when they are given the 2 points. When they are given the 2 points, I want to find out the components of that line joining that 2 points. So here you have to be very careful. Again, I'm telling you here, you have to be very careful. First thing, you must be able to find out initial and terminal point, because based on that only our vector get changed. Okay, so please listen correctly. So now I have taken an initial point as a vector A with coordinates x1, y1, z1 and terminal point as a vector B with x2, y2, z2. Okay, now I need to find out the vector AB. So here we know that, I hope you can see here, the position vector of point A. Position vector of point A is OA, correct? Position vector of point A is OA, or you can also take it as a vector A. Similarly, what's the position vector of point B? The position vector of point B is vector OB or vector B. So I taken here vector OA as the vector A and vector OB as the vector B, and the position vector. These both are the position vector. Now just apply the triangle law of addition for this diagram. Just apply the triangle law of addition for this to get our particular vector AB. Just apply the triangular law of addition. So what is triangle law of addition? We have studied in the second videos, I feel. Second or third videos we have studied. Please just go through my previous videos if you got stuck anywhere. Okay, so now here the position vector of A is OA, position vector of B is OB. Now I want to find out the vector AB. To get vector AB, just I am going to apply the triangular law of addition, in which, so here vector OB is equal to OA plus AB, correct? Vector OB is equal to OA plus AB. Vector OB is equal to OA plus AB. What I want here vector AB, correct? Will agree with me? I want here vector AB. So vector AB, keep it there itself. Just take this OA to the left side. So what it happens? It will become minus OA, correct? Minus OA. So to get vector AB, so I should do here vector OB. I mean position vector of terminal point. So B is a terminal point, correct? B is here. Student. This here B is my terminal point, correct? B is my terminal point x2, y2, z2. Okay, so here I need to find out vector AB. So to get vector OB, I need to do vector OB. That means position vector of B, correct? Minus vector OA. That means the position vector of initial point. I mean position vector of point A. Okay, this if I do, then I get the vector AB. So when I do this process, I get finally, so we know that vector OB, that is x2, y2, z2, and vector OA, that is x1, y1, z1, that means x2 minus x1. You have to do the difference. So difference, how to do the difference? In the last slide we have studied, so in the previous video we have studied. What is that? Just do the subtraction of corresponding elements. x2 minus x1 plus y2 minus y1 plus z2 minus z1. Just do the difference of corresponding elements. You'll be getting that one. So I'm trying to say, please keep in your mind what. So whenever you want to find out the vector which join the 2 points, just do the position vector of terminal point, minus position vector of initial point. This is a formula which we use to find out the given vector which joins the 2 points. So okay, now I got the vector AB. Then what's the magnitude of vector AB? So the magnitude of vector AB, same procedure. What's the magnitude of vector R is equal to x square plus y square plus z square, correct? So here in place of x, x2 minus x1 is there. In place of y, y2 minus y1 is there. In place of z, z2 minus z1 is there. So therefore the magnitude of vector AB, is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. Means whatever the things are there in place of x, y and z, just to make the square of that. That's the difference. Okay, so this is the magnitude of vector AB. So it's important concept, dear students, because next there are some problems which related to this concepts only. So now let's move to the very important theorem which may come for the 3 marks, the Karnataka board point of view, even may CBSE point of view also. So it's one of the important formula or important theorem. So what is the theorem? You have heard already, section formula in the first PU, correct? You are not only in the first PUC, even in the 10th standard also you have studied it. So that is section formula which comes for the 3 marks. So to get section formula, I don't want to go to the full lengthy, just let me make it shortly it is, because these are actually there is one introduction manner, there is one story, I can't do that. 10th standard we have studied. So let me get the diagram first. So what is the theorem? This is the theorem, dear students. What they give, theorem is let A and B be the two vectors. Please note let vector A and vector B the position vector of 2 points. Which are the 2 points? A and B. They are given 2 points, and vector A and vector B are the position vector of that A and position vector of point B. So vector A and vector B are the position vector of point A and point B. Okay, let me take there another point P. Okay, then the position vector of point P, let me take it as a vector R. Position vector of point P is vector R. Okay, so that point P divides AB. Here is AB. That point B divides the vector joining the points A and B with some particular ratio. So what is that ratio they have given? It is m is to n. Here they are given the ratio. It is dividing in the ratio of m is to n. It's dividing in the ratio of m is to n. Okay, then the position vector of point B. I want to find out the position vector of point B. Here B they are given, A they are given. I want to find out the P coordinates. Okay, so the position vector of point P, that is vector OP. Is equal to m into vector B. Okay, can you get here? M into vector B plus n into vector A divided by m plus n. Dear student, please listen correctly. This is when divides the P internally. Suppose P divides the AB externally, there is another formula. Okay, that will move later. So when P divides the internally, line joining the points AB, then the position vector of point P is m into vector B plus n into vector A divided by m plus n. Let us prove this. Okay, so to prove this, let O be the origin. Let O be the origin point with 0, 0, and vector A and vector B are the position vector of point A and point B respectively. Just write on the what they have given, that things only. Write on the given things. Then we know This is simple. Vector OA is equal to vector A and vector OB is equal to vector B. Okay, these things are they are given. So for the diagram, you'll be getting 1 mass. So just write on that. Next, with your permission, let me write here vector R as a position vector of point P. Vector R as a position vector of point P. Vector R as a position vector of point P. That is dividing. That is dividing AB, which already they have only given it is also correct. So that vector R dividing AB, the ratio of M is to N. That R dividing the AB in the ratio of M is to N. Okay. So now again with your permission, I'm going to write it as AP divided by PB. AP divided by PB, I'm going to write it as a M by N, correct? So AP is nothing but M, PB is nothing but N. So AP divided by PB, I'm going to take it as a M divided by N. Just cross multiply. N into this is I'm taking this as N into AP is equal to M into PB. M into PB. That's nothing but N into vector AP is equal to M into vector PB. N into vector AP is equal to M into vector PB. Okay, now I need to find vector AP. What is meant by vector AP? So here, as I said, it's joining 2 points. Vector AP is what here? Joining 2 points. Joining 2 points, correct? Vector AP is here. Vector AP is a vector. Vector AP is a vector joining 2 points, which are they? A and P. That is initial point A and terminal point B. Correct? Then what is the position vector of AP? So here, as already we have discussed in the previous slide, what is that? So whenever 2 points joining, then the vector of a line joining 2 points are terminal point. I mean position vector of terminal points. Here, which is the terminal points? P is the terminal points. So what is the position vector of terminal points? Vector R. Correct? Minus position vector of initial point. What's the position vector of initial point? Vector E. So vector E. Correct? So I'm going to write it as a N into vector R minus vector A is equal to M into, similarly again, vector PB. Here terminal point is B. So position vector of B is vector B. Correct? Minus initial point is P. So position vector of vector P is, so point P is vector R. So this is the way I'm writing. This is the formula which you have studied in the previous slide, just 1-2 minutes before, correct? So now just simplify this one. What I got here is N into R minus A, N into vector R minus A is equal to M into vector B minus vector R. Okay, students, this is not necessary to solve in the exam. This is not necessary to solve in the exam. Directly, if you write this and this up to here, it's enough for 3 marks. Just I'm solving this, how it came. Somebody may ask, sir, how it came. That's the reason I'm solving this one. So now just multiply this N into vector R minus N into vector A is equal to M into vector B minus M into vector R. So now just take N into vector R, that minus MR, I'm taking this side, plus MR is equal to MB, I'm taking this to right side, NA. Correct? Now there is something common. Vector R is common, take it outside. So M plus N left out is equal to MB plus NA. So now I want to write here vector R. I want vector R, correct? I mean I want the vector OP. I want vector OP. OP is nothing but vector R, correct? So vector R is equal to MB plus NA divided by M plus N. This is the answer which we need. This is a theorem which we need to prove. This is a theorem which we need to prove. So please, dear students, it's one of the important theorem for 3 marks. So, and here OP is the position vector of point P when P divides AB internally. This is the formula. Suppose if it divides the externally, suppose P divides the AB externally, then vector R is equal to MB, M into vector B minus N into vector A divided by N minus N. Okay, so be careful. So whenever they are given the points, when point P divides the AB and the vector joining the points AB internally, then the formula is MB plus NA divided by M plus N. when it divides externally, then the formula is vector r is equal to mb minus na divided by m minus 1, mb minus na divided by m minus 1. So this is the theorem which we are going to conclude.